Hey grade 12s, so I just got the copy from Stanmore Physics of the May-June 2025 paper 2. At least this one is a complete paper, so we have gone through the bulk of this paper. We were just missing the last question 10. Obviously guys, I'm not going to show you how to, okay. So as I said, I will not be showing you this, how to handle this question. Whoops. It just keeps on doing the things I don't like. So, whoa. I don't know why I cannot touch those limits. Anyway, let me just adjust my sitting position so that we can go through the remainder of this paper. This proof is in your textbooks, guys. I still don't understand why many of you want to see someone do these proofs, because in my opinion it just shows people are not serious about what they're doing. If you were serious, this should not be something you would want to see someone else do. You should just know how to do, because it's in your books, guys, and you carry them every day to school. So it's a serious problem for me when people just want to watch what they already have available. It just shows, guys, you're passively doing this whole thing. And unfortunately, you are defeating the purpose of these videos. They're not here to entertain you. These videos are here to enhance you. Of course, you only get enhanced if you take ownership of what you learn and take some responsibilities to practice these things. Anyway, guys, it's up to you what you do. At the end of the day, I feel like you are letting us down, because it takes effort to do these videos, and for you to just watch and like it's entertainment, it's not fair. Anyway, in the diagram, O is the center of the circle. So there is O. All right, okay, all right. Now points D and B lie on the circle, so these are concyclic points. We see them. Right, points A and C lie outside the circle, so we see A and C, such that the side AC, can you see, of triangle ADC, this is to suggest this is a straight line. Okay, there's no angulation. So these are very nice things to say. Sometimes it helps to understand. Anyway, so we're told that AC as a side of ADC passes through B, and this is the point on the circle. F is a point on BC such that FO is parallel to BD. So this is indicated, and also DR is equal to RB. Okay, so what do we know? When a line drawn from center and it goes to the midpoint of chord, it is perpendicular to chord. Okay, theorem 1. And if we've got a series of parallel lines here, it means this angle must be equal to that angle. All right, those are corresponding angles. And we also know that this angle must be equal to that angle. Again, these are corresponding angles. And if this is 90 degrees, this must also be 90 degrees. Right, we know that co-interior angles are supplementary. So if this one is already 90, the other one should be 90. Okay, is there more? Yeah, there's quite a lot. There's more angles. That angle equal to that angle, the F on the inside or on the outside. However one looks at it, those are still corresponding angles. Okay, all right, okay. If this is 90, that should be 90. These are alternate angles or angles on a straight line. So there's quite a few things to say, but not a lot, honestly. So we just keep it at what we just see right now. We are told or asked to prove with reasons that this triangle CFO. So we're talking about this triangle CFO and which other triangle? It's CBD, the Central Business District. Okay. This is the stuff that we need to compare. All right, so that is very easy because we know that this angle is equal to that corresponding angles. That angle is equal to that corresponding angles. This is a common angle. So already two pairs are equal. The third pair will also be equal. This is just a standard grade question. So we've got 10.2.1. We understand that we're dealing with triangle CFO and triangle CBD. So these two, we understand that for CFO, we know that angle C is common to both. And on top of that, we understand that angle CFO is equal to angle CBD. Right. These are corresponding angles with OF parallel to BD. Okay. Once you prove two pairs, guys, usually the third pair is not necessary. You understand? Because it just falls into place. But we can say it because it doesn't hurt. We know that FOC is equal to BDC. Okay, these again are corresponding angles with the two lines that are parallel. Okay, we can make a conclusion that indeed triangle CFO is similar to triangle CBD because of the triple A. They are equiangular. Nice. So usually, guys, one mark. This is the same reason, to be honest, the last one for this, because honestly the third pair is not a necessity for similarity. All you need is just two pairs and the third pair will fall into place. So not a big deal. So 10.2.2, we are given that this angle RDO is equal to FCO. So this angle is given as equal to that angle now. Okay. So this makes this big red triangle an isosceles triangle. Okay. So in essence, we understand that the entire BC is going to be equal to, okay, there's just too many notations now, is literally going to be equal to the entire BD. Although BD is itself split into two equal parts. Okay. So this is what it creates. Now it says show with reasons that OF. Now I always just look at what I have. Where is OF? It's part of the small triangle. CD is part of the big triangle. Right. And CO is part of the small triangle. Then BC where is BC? BC is part of the long big triangle. But of course, this statement already is introducing that isosceles triangle. So it's trying to say BD can be replaced by BC, meaning we would be looking at BD and then later on replace it with that. So this is very easy. Again, it just speaks about the two triangles we just proved similar. So we understand that there. Basically, we want that OF, which is part of the small one. So we know that OF divided by, now OF is opposite that angle C, but we saw that angle C is common to both triangles. Which side is opposite that is BD on the big triangle. This should be equal to, now we know CO is part of this small triangle, so we're going to write it CO divided by, now CO is opposite that angle is equal to that, and the side opposite that is DC. Okay, so we can call it CD as it is written. So of course these are the proportional sides of similar triangles in 10.2.1 if we really want to deal with this. So we can cross multiply here easily. So this implies that OF times CD is going to be equal to CO times BD. We've got a story here, but we understand that BD is equal to BC. Why? These are the sides opposite equal angles in triangle. Okay, BCD or CBD. Given that angle RDO was equal to angle FCO. Okay, so this is very nice because we can make a conclusion now that OF times CD is equal to CO. Instead of BD, we just write BC. Replacements. All right, okay, all right. So of course, folks, this is mark worthy. The cross multiplication is not a big deal, but this statement right here and the resultant replacement of what we see there. Okay, good. Now we get to this question here, which is meant to be a higher grade question, seeing the marks involved, and obviously it's going to be a bit taxing on the brain. But could we do it here? I'm not too sure, but let's try and squeeze it in. So this is 10.2.3. So it is further given that DC is 19 units, so this is good. So this is 19.2 units. Okay, now this is an actual length. BD is 12. So this is 12 units. Okay, and RO, okay, this one is not so visible. Let's choose something visible. So RO over RD, so many overlaps, okay, is 3/4. So this means this is 3A. That should be 4A, okay? Nice and easy. All right, so this is all that we are told. Now we need to prove this statement. Okay, that BF is 75/16. Of course, where is BF? There is BF. Okay, BF is part of this triangle BCD or CBD, right? Okay, and then we can see that FO is drawn parallel to the third side of that triangle. We can just re-show this in case it's no longer visible. So those two are parallel, so we know that that satisfies the proportionality theorem. And since we've got units here, we can actually use this to our advantage. Okay, all right, okay. But one thing for sure, we know that RB and RD should be equal as it is indicated. So if this is 12, it means each one is going to be 6 units. It splits into 6. But we understand that BC itself is going to be the 12 units, right? Since we saw that BC was equal to DB or BD. So that's a bit of work. So literally, what we can say is that for us to get here, we will also need that DO. So look at this triangle right here. So if we look at this triangle, ROD or ORD or DRO, whatever, DOR, it's a right-angled triangle because of this statement. And in this business here, we can actually get this side DO, okay? So if we can get DO, then we will be able to do our gymnastics eventually. So there's quite a lot of things to say. Well, we will start by saying we want this triangle to work in our favor. So we'll start by saying, well, in triangle ORD, I doubt if we will finish this whole thing in here. I feel like we might as well just go before we run into problems. So this is 10.2.3. We are trying to be as systematic as possible. In the triangle ROD or ROD, what do we understand? We understand that ORD is 90 degrees. Why is that? This is the line from center to midpoint of chord. It was given to us that R is the midpoint of BD. Nice, that is very important. And we can safely say, well, also in this very triangle, we know that DO squared is going to be equal to RD squared plus OR squared or RO squared, whatever. This is from Pythagoras' theorem. So this implies that DO squared is equal to RD squared is basically 4A. Of course, the A part, we're just playing careful and safe because technically it's a length, isn't it? So we annotate, we don't need to explain how did we end up with what you call that? Yes, that's 3A and the other things. So the annotations, remember the sketch is given, so you annotate it as best as you can. So this becomes 16A squared plus 9A squared. So this implies that DO squared is 25A squared. Therefore, DO is going to be equal to 5A when we take the square root. Okay, guys, so this is one of those annoyingly long questions, and you cannot skip the steps. Very important. We've got a story here, but what, mister? We know that RD is equal to half of BD. Right. That is evident. We're not going to explain. So this implies that RD, which is 4A, is equal to 1 over 2 into 12. Okay, so this implies that 4A is 6. Therefore, our A is 3 over 2 when we solve. So what are we trying to say? We are going to make a conclusion that DO is 5 times 3 over, okay, DO is equal to 5 into 3 over 2, which is going to be equal to, this is 15 divided by 2, that's 7,5 units. So we know that this becomes 7,5 units from the workings. Now, from here on, do we need anything else? I doubt. So we get to the answers that we want. We will say then, what is the story? We know that BF over the entire side BC should be equal to DO over the entire side DC. What is this? This is the proportionality theorem. We need to state the parallel sides. It's going to be OF parallel to BD. In triangle, we need to state this one, CBD. Because when we talk proportionality theorem, we are referring to a specific triangle. Nice and easy. So we continue. So BF over BC, we already established it's 12 units. Of course, we stated it above. Right. We stated that these two were equal. So if one is 12 units, which is already given here, we're not going to justify it now. Over DO, we just found out, is 7,5 divided by DC, which is 2. Okay, so we just cross multiply here. So this implies that we have BF given by 7,5 times 12, all divided by 19,2. All right, so a student who doesn't know maths may want to use a calculator. Unfortunately, where I am, I don't have it. So I'm going to do my old mathematical tricks. So this is equal to, the numerator 7,5 is as good as 75 over 10. You convert these into fractions. Then we multiply by 12, and then we divide this whole thing. It's going to be 192 over 10 as well. Okay, nice and easy. So technically, we're just going to keep it as 75 times 12 over 10 multiplied by, we flip this over 192. And then the magics take place. That divides to 1. We wrote a lot, didn't we? Okay, maybe let's just move this up a bit so that we can spare some space, you know. And then, folks, we can clearly see that these are both even numbers, so 12 has to go once there. But how many times does it go to 192? 16 times. Is that so? Let's check. Let's just say 12 times 16. 6 by 2, that's 12. We carry 1. 6 by 1, that's 6 plus 1, that's 7. And we place a 0, 1 by 2, that's 2. 1 by 1, that's 1. We add these 2. This is 2, this is 9, this is 1. Goodness, that's good. So that's indeed True, of course, we are guided by the answer here. So, of course, folks, learn to do these things in the NPTs. You will not have the calculate. So you might as well know what to do. So this is indeed 75 over 16. Okay, so we can just continue, say BF here, and make the conclusion. All right. It's done. Okay, I need to calculate the size of ABD. ABD. Okay, this is 3 marks, so not probably a big deal. So how do we get ABD? Now I'm thinking for us to get ABD, we first need the cosine rule in this triangle because we've got all these lengths around it. So technically we can use the cosine rule to find that angle. Then through angles on a straight line we can get that nicely. So it's not a very difficult question. So 10.2.4. Of course, however you say this, you just do it, guys. But for me, I don't like to struggle. So I like to get to business. I think the cosine rule here is unavoidable, or even the sine rule can be used. But the problem with the sine rule is that we will have a situation where most of these angles disappear. So I think the cosine rule is the best. So we will say in triangle CBD or BCD. Remember, the naming is interchangeable, so we're not going to worry about it a lot. So what do we know? We understand that DC squared is equal to BD squared plus BC squared minus 2 times BD times BC times cos of angle CBD. Right, that's the cosine rule. So this implies DC is 19.2 squared into BD is 12 squared plus 12 squared minus 2 into 12 into 12 cos of CBD. Unfortunately, here I'm going to need the calculator, so I don't know how I'm going to handle the business. By the way, we want to isolate cos of CBD is going to be this 19.2 squared minus the sum of these two. This is 144, 144, so we can just say 2 times 144. Right, and then we divide this whole thing by, again, minus 2 times 144. And we will say, therefore, CBD is going to be the arc cos of this whole thing, 19.2 19.2 squared minus 2 times 144 divided by minus 2. Wait a minute, what did I do here? Oh yeah, this is good. This is gonna be 2 times 144. Okay, so I need my calculator, so let me go grab it. So let's just do it nicely, one step. Arc cos of this situation here, it's gonna be 19.2 squared. Sorry, so this is minus 2 times 144 divided by minus 2 into 144. Of course, the negative on the denominator will undo the negative that would have come on top. So this is 106, 26 degrees. Of course, at this point, this is how it is. We will say, but we understand that this angle CBD plus angle ABD should give us 180 degrees. These are angles on a straight line. Grade 8 concepts, isn't it? So this is 106,26 degrees plus ABD is 180 degrees. Therefore, ABD is going to be 180 degrees minus 106,26 degrees, which is what we get. So here I'm just going to subtract 180 straight up. So it gives us a 73,74 degrees. Yeah, is like this. Great, so that's it, guys. That's it, guys. So not a very difficult question 10. I expected stones. But again, if you don't understand ratios and proportion, which, guys, I taught you these things, and also knowing how to look at your structures and use them effectively, you will always suffer. It always happens. When someone is not paying attention to detail, they always lose. We never even marked our... Wow, this is gross. Okay, we didn't mark this 6 marks. Of course, this is key. Pythagoras is not really a big deal at this stage. But what is the answer is what matters here. And of course, finding the value of A, however you got about it, and eventually getting this. Good. So this statement and reason, prop theorem, interesting, 5. And of course, the answer was already given. Now I'm thinking, where could we be giving the marks? Perhaps the substitutions, because, guys, the gymnastics are not really that fancy. I mean, one could have punched it on the calculator from here. So we can say just substitutions here. Was good enough. The answer was already volunteered, so everything just had to tie up nicely into the answer. I was just trying to showcase some mathematical gymnastics here that you need to understand, so that when you are not using a calculator, especially for a question like this, it can show up in the NBTs. And you may have to deal with it without a calculator. So you should know how to convert from decimals to fractions, and then do the due diligence, and you should be good. Okay, that was 6 marks up there. And here, setting up the cosine rule, writing it in terms of what we are given is good. The result is more important, and the result also. The rest, these are grade 8. Okay, this one is grade 11, 12. Okay, we can accept the reason, but the calculation, not really that big. Substitutions, not too big. But I suppose the answer there is more important. This is quite a powerful statement, though, but again, it's a grade 8, grade 9 theorem. So, not really important. Okay, guys, so that's it for these 20 marks, okay? They were not that difficult after all. As you can see, the bulk of these marks came from the proof, which it's just a fat 6 marks for just reproducing what is on the book. And of course, the last question. I hope you enjoyed the video, guys. So I'm gonna be attaching to this video the main question. What did I say? The main video of the review of this paper. Unfortunately, I ended up with the split because I didn't have this question on the one question paper that I got of essay exam papers. So this one was friendly enough, but it was too late, I guess, later than I obtained that first copy. So yeah, I hope you guys have seen that there wasn't really so much difficulty on this paper too. Of course, 10.2.3 is a definite higher grade question. If you don't think so well, you're not gonna win there. Anyway, goodbye.